My name is Thomas Niffel and I'm going to describe my code. So first I start with the main function. In the main function I created options, and in order to create options I had to import this module called argparse, and here I created an argparse argument object, and here this line enables the options to be added, and the object is filled with the arguments here. And these options are made mutually exclusive, so everything what is within this group is mutually exclusive. So I can demonstrate it here. For example, if I enter here option my R, which is the receiver, and option T, which is the transmitter, and so this one is displayed saying that these two options can't be used together. They can be used only separately, like this. Like for example, if I enter the R option, the server starts in listening mode. The if, elif, and else statement are used to call for example, this if statement, if I is used to call the server. So if I enter into the command line the R option, it calls the server, and this argument here is passed to the server. If I enter the port number I want the server to listen on, and this elif is used for the transmitter, in this case for the client. So if I enter T on the command line, the client is called, and I can specify here the IP address, port number of the IP address of the server, the port number of the server, the port that the server listens on, and I can even specify the length of the bytes that will be sent to the server and echoed back to the client. So to demonstrate that, I entered here on the receiver side, which is the server. I entered these options, yeah, R, P for port. So the server now is listening, as you can see, on port 1990. Now when I will run the client, I have to specify the server's IP address, which is here. Now this one specifies the length of the bytes I want to send to the server, and this one is the port the server is listening on here. You can see that. So when I run that, you can see that the bytes were sent over to the server, sending here 7,000 bytes that I specified. Then the server received the bytes, and then the server sends the bytes back here to the client. If I don't enter any argument on the command line, the help menu is displayed like this here. Now I'm going to describe briefly the server side. So it means here the server socket is created, and these ones specify what type of socket will be created. So this one is for the IP connection, and this one is for the TCP connection. Here the newly created socket is bind to the address and the port. So this empty string means that the server is willing to accept any connection from the client, not just the specific connection. Now, once the address of the socket is set, a listen method is used to tell the kernel OS that the socket is ready to accept connections from client, and connections requests from the client is accepted by this line here, by the accept method, and this is a blocking function. So now the server at this stage is waiting for the client. So you can see here that the server is now listening on port 1990. I specified the port 1990 with this option, and is waiting for the client. Now if I go to the client side here, so the connection is established with this method, connect method. So once the connection starts, the client send a SYN packet to the server. So I can demonstrate it here in the Wireshark. So you can see here that the SYN packet was sent to the server. And the server sent back to the client SYN acknowledge flags, and then client again sent acknowledgement to the server. So and after the freeway handshake is finished, the connection is agreed, and the bytes can be sent to the server. So as I said, once the connection is made, they are in the client. In this case, the bytes, the random bytes are generated with the help of this statement here, urandom method. So in order to use that, I imported this OS module, and it generated random bytes that were sent to the server and echoed back from the server to the client. So you can see here that they were sent here. I will demonstrate it here in Wireshark. So here from the client, I sent 7,000 bytes. So you can see that the receiver, which is the server, received here received the segments here down here, but the client sent here you can see that the client sent 1 2 3 4 5 segments and acknowledge the segments, and the receiver, which is the server, echoed back the bytes that were previously sent by the client. So, and this line started the timer. So when the bytes that were sent to the server were sent, the timer started, and then the client received here back the bytes from the server. So it kept receiving the bytes, and when there were no more bytes, it exited the while loop and printed this message. And here here the timer was stopped once there were no data, and here the round trip time were calculated in milliseconds. So here I demonstrate how I send the bytes from the client to the server. So first I started the server in receiver mode, and then I specified the port that the server will listen on, and so I start that. Now the server is in listening, waiting for the client. Now I start the client. I enter the T option. I specify the IP address of the server, the port number the server is listening on, and here with the L option I specified how much or how many bytes I want to send over. So when I send it over, you can see that the message that the bytes were sent and then received back from the server, and here is calculated the round trip time in milliseconds, and then the connection was closed. On the server side, you can see these messages here that the connection was made with the client, and the bytes were received by the server. So as I mentioned earlier, here you can see that the 7,000 bytes that I specified with the L option were sent from the client, which the client has a like a randomly assigned like a port number, and the server has this port number 1990 that I specified with the P option. And you can see that 1, 2, 3, 4, 5 segments were sent to the server before they were acknowledged by the server here, and then the server sent back again 1, 2, 3, 4, 5 bytes back to the client, and then they were acknowledged here. And then once the whole process was finished, all the bytes were sent back to the server, then the sockets needed to be closed, and you can see that the sockets were closed here in the you can see that in the Wireshark. So the clients and fin flag to the server, and the server replied with the fin act, and then the client sent acknowledgement. But usually it's done normally it's done with 4 packets, but in this case there are 3 packets because a technique called piggybagging was used. So it means that there are no like 4 packets but only 3. And here this you can see that on the on the server side this close method was used to close the socket, and on the server side as well, here is it's closing the socket. I also introduced this if statement, so it actually doesn't allow the user to enter more than 8,192 bytes to be sent to the server. So I can demonstrate it here. For example, I enter 10,000 bytes here. So if I want to send it over to the server, it displays this message: buffer length cannot be more than 8,192 bytes. Please try again. And it says closing the socket. So it limits what the user can enter there with the L option. Okay, thank you for watching my video, and bye.